So just to kind of recap, last year I was here and we talked about the Esri QPS hydrographic workflow or seafloor mapping workflow, where we wedge our solutions, so our marine data acquisition and positioning system, which is Quincy, our hydrographic data processing, which is Chimera, and then our 4D visualization analysis tool, Mouse, right in between the Esri workflow. The key new feature last year we talked about was a Chimera guided workflow, and hopefully some of you had a chance to attend Samantha's workshop earlier this week, where we really have looked to make, basically to eliminate human error in the hydrographic processing component, as well as make it easy, or easier, let me put it that way. I can't say it's never going to be easy. So basically it's fairly simple. It's a guided workflow, and within 5 clicks, you're basically at the data processing end now. Now we'll be able to load in raw data and get yourself into a nice dynamic visualization space to begin your data processing. So within seafloor mapping, we're during every stage of the hydrographic workflow, there is data that tells us things to help us utilize and help us do our job better and to help find things. And the key though is like, okay, where does that data exist? And then how do I get that into a space that allows me to be able to better utilize it and allow the data, and this is straight from the Ocean Exploration Forum, to tell me what's there. And also be able to extract more information. So not just what's on the seabed, but also looking at the intensity of the return or the side scan information, as well as the backscatter information off the seabed. Then begin to correlate that with the water column information. So within the, little thingy working? Oh, well, anyway, if you, within the water column fan itself, there is data there. We're not just limited to the seabed when we start looking at acoustic information. During the processing, there are several visual cues and tools within the software that can be utilized to help you do your job better and using different components of the data itself. By incorporating these tools into a dynamic visualization space, we allow the data to tell us what's there and what is good and what is bad. So you look here, this is data straight off the ship, and you look at it and go, oh, that actually looks pretty darn good. Okay, well now let's rotate it and let's get another look at it. And still looks pretty decent to me. I looked at it, I was like, oh, there's nothing wrong with this data set. But then I went ahead and I said, okay, well, let me, instead of, you're looking at a gridded information here. So rather than looking at the mean depth within each grid cell, let's look at the shallowest depth, which is the way NOAA, the Corps of Engineers, several hydrographic organizations look at their data set, because it's not, in hydrography, it's not so much about the mean depth, but what they really want to know is basically what poses a hazard of navigation. It's always that shallowest data point. So when I bring that up, all of a sudden we start to see spikes in the data set, or anomalies, at least things worth investigating. And then it's like, okay, let me hone that in even better. So rather than looking at just color coding it by depth, let's go ahead and color code it by the standard deviation of the seabed itself. And then spikes start to show up even more, or anomalies in the data set. And now I zoom in, I go, okay, well now I got to get rid of these data sets. So now we could just start using really simple tools. We could draw a line around these data and then quickly get rid of them, and now your data gets clean. And what we've been doing is we've been calling this spike hunting, and we just basically move this lasso or this circle from spot to spot and just investigate these spots quickly. What that allows us to do is, okay, well, we know where the clean data is. Now we could clearly see where the data is not so clean, and we could move on to to just move from bad data point to bad data point. So I talked about different components. So we looked at just the bathymetry, and now we're like, okay, well, my favorite thing is the water column. I've always been fascinated by what I could extract out of the MultiBeam data itself, the raw beamform imagery data. And if you look here, this is actually a slice right through, this is a volcano off the Philippines. And if you look closely, you start to see an anomaly in the water column data itself. You're like, oh, geez, I wonder what that is. And I said, okay, when we take another slice, let me look at it across. Okay, well, it's there as well. So it's not just something, it's consistent across multiple pings within the data. So we go ahead and we digitize that information, and as it turns out, this is a volcano, and this is this is the volcano venting. Then I take this information, I go, okay, let me take this all together now. And I could take what I learned in the last two examples, expand those to see how much can be found within a single scene itself. So in hydrography itself, we began using the water column information, as mentioned, to look at the least depth. So what happens is when you're running a multi-beam system, you have 512 beams, for instance, and you have to choose where the data point is going to reside within each beam. And a lot of times that's not going to be the shallowest depth. So then we revert back to the water column information to go to start looking at it. What I end up finding is that there's more than that. And you see this green blob in there. And I digitized that information, and it turns out it's a fish school. Then I went ahead and looked at the backscatter information to see now why is that fish school not on top of the boat on the wreck we're looking at here, but why is it off to the side? So I went ahead and overlaid the backscatter information, and sure enough, I'm starting to see a feature on the, on the lower part of the screen there. Digitize that, and it lines up well. Then I went ahead and said, okay, let's look at I believe this is the rugosity information, or it's basically to measure how rough the seabed is. And sure enough, it lines up. The rougher information is lined up with where that fish school's at. Then I looked at the slope, similar thing. So we could see it's a steep area with an area of lower rugosity or lower slope in between, probably softer sediment, some sort of a reef, anticline, syncline type feature on the bed. Now we could say, okay, well, what is it that what is that? So now we could take this information and let's go ahead and bring the video information into the same scene. And now we could start to do classifications as we're looking at the video information, tie that to a database as we're moving along with the video and on that route, and say, okay, yeah, and classify or color code it by habitat, for instance. And we're taking it even a step further, and we're looking at multiple frequencies within the data set. And we could take this. So what we've done is that this is actually a 100, 200, 400 kilohertz survey from the same sonar system. So looking at multiple frequencies, and we're color coding these now. We're taking the 100, I believe, is red, the 200 is blue, and the 400 is green. And we could start looking at these and how these different frequency responses off the seabed relate to them as well. And of course, we're taking this information and we're tying this directly with, we have a bidirectional link with the Esri Geo Database. So now you can bring this in and log this directly into your Geo Database as well. So in summary, I still got 2 minutes, I'm doing really good. Humans are inherently visual creatures. During every stage of the hydrographic workflow, there's data that tells us things to help us do our job better. In the processing, there are visual cues within the software that can be utilized to help you do your job, find out things, and find where the good and the bad may lie. And also the data has different components that, that further improve our ability to tell us these things. And also now we're moving beyond discovery of the seafloor within multi-beam data. And we're exploring what other information exists within the data, what story is it telling you, and what should we do next? And now we're looking at the fusion of different data sources. So with that, we're now looking within QPS as a company as a whole, we're looking now just to evolve even further beyond that, even further beyond acoustics, and we're going to start looking at other data sources as well. And just this is a quick grab, this is something I've been playing around with in the past, and looking at, say, fusing hyperspectral data with, say, this is actually, I believe, data from a fluorometer on a glider. So, we're moving forward, and with that, I'd like to say thank you to Esri for, once again, having us, and thank you all for listening.
Thank you, Chris.